Good morning, students. I am Manikant Mishra, Modern English School, New Area. So as yesterday I have mentioned in the video that more or less I have discussed with you the periodic classification of an element, and I have asked to you that if any topic which I have not discussed, please let me know. But only one student have informed to me that yes, you have discussed all the topic, nothing is left. So it means that then I should go for to discuss the some NCERT question and answer. So let us start to discuss some of the question answer based on the NCERT, and later on we will discuss apart from the NCERT. First we will discuss NCERT question answer. So the very first question is, did Dominus triad also exist in the column of Newton's law of Octane? Yes, as we know that the first Dominus triad was first triad formed by Dominus was lithium, sodium, potassium, and that these elements also exist in the Newton's classification. These three elements what Dominus put in a group which is known as a triad is also these three elements lithium, sodium, potassium also exist in the Newton's law of Octane. So we will write yes, Dominus triad also exists in the Newton's law of Octane, as for example lithium, sodium, potassium. Now next what were the limitations of Dominus classification? As you know that he could form only three triads: lithium, sodium, potassium. So the second triad calcium, strontium and barium. Third triad chlorine, bromine, iodine. After that, the elements which were known at that time could not fit it into the triads. So it means all the elements which were present in his time where he could not fit it all those elements into the triads. So his classification becomes unsuccessful. Now next question. What were the limitations of Newton's law of Octane? As you know that he said that when the elements are arranged on the basis of increasing atomic mass, there is a resemblance of the properties of the first element with the eighth element, like the octave of music. So it means every eighth element resemble with the first elements. Every eighth element properties resemble with the first element. So this was applicable only up to calcium only. After calcium, these kinds of resemblance in their characteristics, these kinds of resemblance of their properties was not found. One. The second, he assumed that that after 56, it means there were 56 elements present in his time. He thought that there will be no more discovery of elements. This is the only 56 elements are only is present in the nature. Next, he placed dissimilar elements. He placed dissimilar elements along with the other elements, like along with the chlorine, chlorine, bromine, he placed cobalt and nickel. The cobalt and nickel has entirely different properties from the fluorine, chlorine and bromine. Not only that, he placed two elements in a single slot. In a single slot, he placed two elements like a cobalt and nickel. So these are the drawback of the Newland's classification. Next, use Manley's periodic table to predict the formula for the oxides of the following elements. As you know that the Manley, before he starts to arrange the elements, before he classify the elements, he studied the chemical properties of an element by taking the hydrogen and oxygen, because these two elements were very reactive elements. So he observed that the metals or the elements, how they react with the hydrogen as well as with oxygen. So in his periodic classification, you see that RH or RO, R2H or RO, like this way the different hydrides and different oxides of the corresponding elements he has written in general form at the top of the Manley's periodic table. So R is a general form of the element. So here, but it is not here in general case, just I have given you a reference. Like here, the element is potassium, which is in the Manley's periodic table present in a first group whose valency is 1, and if it combines with oxygen, and oxygen has valency -2. So if you cross each other, then its formula for its oxide will be K2O. Similarly, carbon is present in 4A. Its valency is 4 and oxygen has valency 2. If you cross each other and simplify it, then formula will be CO2. Next, aluminium. Aluminium is present in 3A in Manley's periodic table. Aluminium has a valency 3 and oxygen has a valency 2. Cross each other, then Al2O3. Similarly, silicon is also found in group 4A. So silicon has valency 4 and oxygen has valency 2. Cross each other, SiO2. Similarly, barium is present in group 2. Its valency is 2. So, and oxygen has also valency 2. So barium oxide Be +2 -2 cancel. So BaO. So K2O, CO2, Al2O3, SiO2, BaO are the formula for their oxides. Next, besides gallium, which other elements have since been discovered that were left by Manny in his periodic table. So as you know that while arranging the elements, Manny left the gap. He experienced that these elements are missing, so he left the gap for those unavailable elements. So he left the three gaps. One, it is mentioned in here, the beside gallium. Which other two elements have since been discovered that were left by Manny in his periodic table? That is germanium and scandium. Germanium was below silicon. Below silicon he left the gap, and the later on discovered element name is germanium. And below boron also he left the gap, that later on discovered the name of these elements is scandium. What were the criteria used by Manny in creating his periodic table? As you know that he said, which is also known as Manny's periodic law, the properties of an element are the periodic function of their atomic mass. The physical and chemical properties of an element are the periodic function of their atomic mass. What's the basis of the classification? If I say the same thing in a different way, or in a simplified way, on the basis of increasing atomic mass, keeping in mind the properties of an element, similar properties of an element are placed together. Now next, why do you think noble gas were placed here? Why do you think the noble gas are placed in a separate group? As you know that noble gas are also known as inert gas. Why it is called inert gas? Because these elements at ordinary condition do not take part in a bond formation, do not take part in a chemical reaction. That's why these elements are placed in a separate column. So its nature is entirely different from rest of the elements. That becomes the need to place in a separate group. How could the modern periodic table remove various anomalies of Manny's periodic table? As you know that the Manny's periodic table was running of certain demerit, like a position of isotopes. There were no place for the isotopes in the Manny's periodic table, since the elements were arranged on the basis of increasing atomic mass. There was a need to give separate place for isotopes. That was not done. But in modern periodic table, since modern periodic table are constructed on the basis of increasing atomic number, so the isotopes have the same atomic number but different mass number. So one atomic number represents all the isotopes, as for example 1H1, 1H2, 1H3. So all the hydrogen has same atomic number. So once if you put the hydrogen, that one atomic number, for one atomic number, it represents all the three isotopes. Similarly, oxygen 8O16, 8O17, 8O18. All the three oxygen have the same atomic number 8. So once if you place the oxygen at according to atomic number 8, then it represents all the 3 isotopes. Second, cause of periodicity. Mandy could not explain why there is a recurrence, why there is after certain interval the elements are coming under the same vertical column and possess similar characteristics. He could not explain, but in the modern periodic table has successfully explained the repetition of the same number of valence electron is the cause of the periodicity. Periodicity means the repetition of the properties of an element after certain interval. So, since all the elements under the same vertical column which comes after a certain interval possess the similar characteristics because of the having the presence of same number of valence electron. Like after lithium, 8th element comes sodium. Again after sodium, 8th element potassium. After potassium, 18 elements then come lithium, sodium, potassium, rubidium. So these are the certain interval 2, 8, 8, 18, 18, 32. These are the certain interval. Name 2 elements you would expect to show chemical reaction similar to magnesium. What is the basis of your choice? Just now we have discussed the cause of periodicity means the properties of similarities in their properties is the cause of the same number of valence electron. So here there is a question, name 2 elements you would expect to show chemical reaction similar to magnesium. What is the basis of your choice? As you know that the magnesium has atomic number 12. So its electronic configuration 282. So we will find that the elements whose valence electron, if it is a 2, then it will be resemble with the magnesium. That is a beryllium. Its atomic number is 4. So the electronic configuration 2, 2. Calcium 20, 2, 8, 8, 2. So again you see the beryllium and calcium has same number of valence electron. So the beryllium magnesium will have the similar characteristic with magnesium. So you see it. If there is any doubt, please let me know. Thank you. Have a nice day.